Okay, so let's continue with our chapter. So in this particular chapter, we already learned about how to estimate mu. Okay, how to estimate mu. Okay, with x bar. Okay, how to estimate sigma to okay, sigma is population standard deviation. S is for sample standard deviation. And also we learn on how to estimate sigma square using S square. Okay, so we have given formula for calculating this. Okay, but what are the different? Okay, the difference is if you use symbols like mu, sigma, sigma square, it is actually for population. Okay, population means that your sample is from population, and you need to remember the definition of population is all element. Okay, example, if you use archi student, all archi student. Okay, and when you calculate the mean, the standard deviation from that data, okay, so it means that you have all students data. Okay, the symbol you will use is mu, sigma, and sigma square. Okay, but suppose that now you are doing your project, you only sample a few of your or a few of archi students. Okay, so a few of archi students too, we call it as sample. And when we're talking about samples, when you calculate the mean or the average from samples, the standard deviation from samples, okay, the variance from samples, you will use symbols such as x bar, s, and s square. Okay, so that's the difference. Okay, the formula is given. Okay, make sure that you know how to transfer the information into the formula. Okay, and last week I discussed about interval estimation, where instead of you estimate by using a single value, we have the mean and the max value. It means that we have a range. Okay, but the mean and max value is depending on whether you use the Z distribution or T distribution. Okay, and this particular cases, okay, depending on whether the sigma or sigma square from the information is known or sigma square is unknown. So based on this information, you can determine to calculate the interval estimation. You have to use Z distribution or T distribution, and based on this, Z distribution and T distribution is actually from your from your uh, from your table. So means that this is actually this is actually from table, from statistical tables, stats table. Okay, so still remember I asked you guys to have statistical tables. Okay, right. Okay, now we continue with what if, okay, instead of one group, as examples, dalam case interval estimation, you only have one group of students. Okay, you want to estimate the mean for artist student je. Okay, but now we have a different way. Suppose that you want to compare. Okay, the words here is compare. If you want to compare the population mean between two different groups. Okay, so as examples, mungkin you say that you want to compare the mean between the FSG student and Archie student, right? So when we talking about comparison, okay, now you have two means. Okay, two mean means that mu1 and you will have mu2. Okay, depending on questions, you have to assign lah. Okay, which one is mu1 and which one is mu2. Mu1 maybe group the information is from Archie student. Okay, mu2 the information is from FSG student. Okay, now you want to compare. Okay, you want to compare. So this particular situation, we call it as confidence interval for the difference between two means. Okay, and as the confidence interval for a single mean, okay, for ni it's only one group, one group. Okay, we also have cases depending on whether the sigma or sigma square is known or sigma square is unknown. Okay, and we will take a look at the example later. Alright, and for this particular group, okay, this particular group also divided into two, okay, which is independent and dependent. Alright, so for independent, the example is we have two different group as example as Archis and FSG, whereby if the group is dependent, okay, the example is suppose that you are doing some sort of testing whether your diet, contoh whether your diet is effective or not. So we have observation for after and before. Okay, before and after lah. Okay, because before diet and after diet. Okay, before and after. Okay, and you take the test with the same sample units, means that the same person. So means that because of the sample unit is the same, the difference is only because of the treatment that they receive, means that the diet, so it belongs to dependent. Okay, and for today's session, I will talking about the independent. Means that we have two different group. As example, here we have so this is the details explanation on what are the difference between independent samples and dependent samples. Okay, so let's take a look at the definition. Okay, two samples are independent if they are drawn from two different population and the element of the first sample have no relationship to the element of the second sample. Okay, so means that suppose that you are taking the first samples from FSG student and the second sample from Archis student. So means that Archis and FSG is two different population. Okay, maybe you want to do population UiTM Shah Alam and UiTM Jengka as examples. Okay, it can, because it's from two different population, it belongs to independent. But for dependent samples, two samples are dependent if they are drawn from two different population and the element of the first samples have relationship. Okay, means that we can say it is a matched pair sample. Okay, so example given to you here is the blood pressure of the same people before and after they receive a dose. So my examples before this, I use diet kan. Suppose that you want to measure whether the diet program is effective or not. So we take the observation before diet treatment and after diet treatment. Okay, and for this particular case, since that we want to know the difference, so what we try to do the interval estimate is actually okay, mu1 minus mu2. Okay, mu1 minus mu2. And why we say mu1 minus mu2? Because, okay, suppose that, okay, let's say we estimate, okay, mu1 is equals to 20. Okay, mu2 is equals to 20. So when you do the operation, the difference between mu1 and mu2, so what you get is 20 minus 20, so you will get 0. Alright, so now we want to know whether 0, okay, we want to know whether 0 is within the interval. So if 0 is within the interval, we say that mu1 and mu1 is equals to mu2. Okay, mu. Okay, if 0 is not within the interval, means that when we calculate, okay, the value of our interval estimation, 0 is within or not, okay, not within the interval. Okay, so mu1 is not equals to mu2. Okay, so the population mean is different. Alright, and still we use x bar and x bar 2, x bar 1 as x bar 2 to calculate the confidence intervals. Alright, so the concept is still the same. So to clearly explain this, I will discuss about this example in next video. Alright, okay, so I will stop here and we will continue with examples.